Now try to understand that. So in previous video, we discussed that if our x part means, suppose the second order differential equation is d2y dx2 plus p1 dy dx plus p2 y equals to x, and suppose this x is a exponential function, then how to solve the particular integral? And if the x is any trigonometric function, not any sin x or cos x, then how to find particular integral? And if there is any polynomial, then how to find particular integral? But in this video, we are going to learn if this x is any mixed function. Mixed function means with exponential, there is any other function v. This v can be any function. Okay, so this v can be a trigonometric function, also the polynomial. Okay, so then how to find particular integral? Okay, then in this case, the particular integral will be 1 by f of d into e to the power ax into v. So we can write e to the power ax by modifying this operator by f of d plus 1. So here basically we have to replace this d by d plus a if we want to shift this exponential function here. Okay. So now try to understand this method with few examples. So here we can write the given differential equation in the form of d square minus 5d plus 6y equals to x square e to the power 3x. So to find complementary function, we have to find the auxiliary equation of the given differential equation 1. Okay. So our auxiliary equation will be m square minus 5m plus 6 equals to d, and next we have to find the root of the equation, so it will be 2 and 3. So this 2 and 3 are both real number but distinct or unequal. So therefore the complementary function ycf will be c1 e to the power 2x plus c2 e to the power 3x. The c and c1 and c2 are both arbitrary constant. Okay, so now next we find the particular integral. Okay, y, yeah. So ypi will be 1 by f of d. So here f of d is d square minus 5d plus 6 into x square e to the power 3x. So we know that if there is any function, with exponential, so we can write this exponential here e to the power 3x, and we have to change this d operator d by d plus a. Here the value of a is 3, so d plus a will be d plus 3. So in the place of d, we have to write d plus 3. So d plus 3 whole square minus 5 d plus 3 plus 6 into x square. Okay. So in next step, we have to modify this function. We just have to simplify this. So it will be d square plus 6d plus 9 minus 5d minus 15 plus 6 into x square. Okay, so we can write this in the form of d square plus 5 plus 6 minus 5, so it will be plus d, and it will be cancelled out. 9 plus 6 is 15 and minus 15, so it will be cancelled out. Okay, into x square. So now we know that it's just a polynomial x square, and the d operator is 1 by d square plus d. So how to calculate this? We can write d operator in the form of 1 by d into 1 plus d whole to the power minus 1. Since it's a polynomial here, so we have to write this d operator in this form. This e to the power 3x remain as it is in this solution. So it will be e to the power 3x into 1 by d, and we can write 1 plus d to the power minus 1 in this form. 1 minus d plus d square minus d cube. But the thing is, how many terms we have to write here? So for that, roughly we have to calculate that if I apply d once in this function, so it will be 2x. Okay, and if we apply twice in this function, it will be 2, and after that, for each and every derivative in higher order derivative, this function, it will be 0. So we can think in this way: d to the power n x square equals to 0 for any value greater equals to 3. Okay, so just we have to write the first 3 terms. We don't need to write this term because we know that this value, it will be 0, and after this value each and every term will be 0. Okay, so now come back to this calculation. So x square, so e to the power 3x 1 by d, the first term will be, we have to multiply this with this, so it will be x square. Next, it will be 2x, and it will be 2. Okay, the second order derivative. Okay, so basically if I derivative this function once, it will be 2x, and if we derivative twice this function, it will be 2, and after each and every term, it will be 0. So don't need to write this. Okay, now there is one thing that here we know that d is basically derivative. Okay, and what will be the operator 1 by t? It's basically the equivalent to integration. Okay, so since it's equivalent to integration, so if there is any 1 by d, just we have to integrate this function with respect to x. Okay, with respect to x. So the answer will be x cubed by 3 minus x square plus 2x. Okay, so this is our particular integral. So therefore, the y pi is e to the power 3x into x cubed by 3 minus x square plus 2x. Okay, so therefore, the general solution of the given ODE is y equals to ycf plus ypi. Okay, so our ycf is c1 e to the power 2x plus c2 e to the power 3x, and ypi is e to the power 3x into x cubed by 3 minus x square plus 2x. So here you have to mention that c1 and c2 are arbitrary constant. Okay, so I hope the solution the solution is clear. Now pause this video and try to find the solution of this problem. So now let me explain how to solve this problem. So we can write the given differential equation in the form of d square minus 5d plus 6. I think the auxiliary equation, it will be same as previous problem, cos x. So this is our equation 1. So we already calculate the auxiliary equation. So let me directly write, but in exam you have to calculate this. Okay. So let me write directly because it is same. Okay. But how to find YPI? Okay. So here YPI will be 1 by d square minus 5d plus 6 e to the power x cos x. Okay. And we know that if there is any exponential function given, in next step, we can write this exponential function here, and we have to modify this operator by d plus a. Here the value of a is 1, value of a is 1. So we can modify this d by d plus 1 whole square minus 5d plus 1 plus 6 into cos x. Okay. So if you simplify this, it will be d square plus 2d plus 1 minus 5d minus 5 plus 6 into cos x. Now in next step, we can write this d square. So 2d plus 2d minus 5d. So it will be minus 3d, and 6 plus 1, 7 minus, so it will be 2 into cos x. Okay. So it's just a problem of trigonometric function. So we know that if there is any d square, we can replace this d by minus a square if the value is not equals to 0. Okay. So if there is any d square, we can replace this value by minus a square. So here the value of a is 1 because the function given cos x. Okay. So in next step, we can write 1 by, in the place of d square, we can write minus 1 square minus 3d plus 2 into cos x. Okay. E to the power x. So ultimately it will be 1 by 1 minus 3d cos x. Okay. There is one thing that we can apply the rule if there is a d square, but here in d operator function, there is only d. So first we have to make this d to d square. So how to make this d to d square? Just multiplying numerator and denominator by 1 plus 3d. Okay. So it will be 1 square into 3d square. Okay. So in next step, we can write 1 plus 3d divided by 1 square is 1 minus 9 of minus 1 square. So here we can put d square to d minus 1 square because we know that this value is not equals to 0. Not equals to 0. So we can put the value minus 1 square in the place of d square. Okay. So therefore, it will be e to the power x divided by 10. There is this operator is basically 1 plus 3d. So if we multiply 1 with cos x, it will be cos x plus 3. And if we derivative this function once, if we derivative this function once, it will be minus sin x. So ultimately, our required pi is e to the power x by 10 into cos x minus 3 sin x. Okay. So for general solution, equals to YCF plus YPI, and just you have to put the values of YCF and YPI. So YCF is C1 e to the power 2x plus C2 e to the power 3x, and our PI is e to the power x by 10 cos x minus 3 sin x. Okay, and you have to mention that C1 and C2 are being arbitrary constant. Okay. Now pause this video and try to solve this problem. I think it's a similar type of problem. So try to solve this problem by yourself. Okay, then check the solution. So to find YCF, what we do, first we find auxiliary equation. So here the auxiliary equation will be n square minus 2n equals to 0. So therefore the roots of these equations are 0 and 2. It's real but unequal. So therefore the complementary function will be C1 e to the power 0x plus C2 e to the power 2x. Okay. So we know that e to the power 0 is 1. So therefore it will be C1 plus C2 e to the power 2x. Okay. Here the C1 and C2 are arbitrary constant. Okay. Now it's time to find particular integral. Okay. So here particular integral will be 1 by d square minus 2d into e to the power x sin x. And we know that if there is any exponential with other function, here the other function is a trigonometric function. So we can write this exponential function here, e to the power x, 1 by, and we have to modify this d by d plus a. Since the exponential function given here, e to the power 1 into x, so the value of a is 1. So we have to modify this d by d plus 1 whole square. So d plus 1 whole square 2 into d plus 1 into sin x. Okay. Now in next step, we have to simplify this d operator. So here the d operator will be e to the power x 1 by d square plus 2d plus 1 minus 2d minus 2 into sin x. Okay. So we can write this d operator in the form of d square minus 2d plus 2d, it will be cancel out. So plus 1 minus 1, so it will be minus 1. Okay. Sin x. So it's a totally function means particular integral problem of for a trigonometric function. So the given trigonometric function is sin x. So the value of a is 1. Here roughly we have to think that if I put minus 1 square here, so is it 0 or not? If this value, if the functional value is 0, then we have to apply different method. But here I think in this problem minus 1 square minus 1, so it will be minus 1 by 2. So basically it's a non-zero value. So directly we can write one by minus 1 square minus 1, since this value is non-zero value. So ultimately the particular integral ypi, it will be minus e to the power x by 2 into sin x. Okay. So therefore the general solution is y equals to YCF. We know that the YCF is 1 plus C2 e to the power 2x plus YPI. YPI is minus e to the power x by 2 into sin x. And here you have mentioned that C1 and C2 are arbitrary constant. Now similarly, I think it's a again similar problem. Okay, so pause this video and try to solve this problem by yourself, then check the solution. We can write the differential equation in the form of d square minus 2d plus 1 y equals to x e to the power x. Okay, so first we have to calculate YCF. What will be the YCF? For that we have to calculate auxiliary equation. So auxiliary equation will be n square minus 2m plus 1 equals to 0. So therefore the roots are 1, 1. Okay. So it's a real root but equal root. Okay. So therefore the complementary function will be c1 plus c2x into e to the power 1 into x. So we can write e to the power x. Okay. So now find ypi. So here ypi will be 1 by d square minus 2d plus 1 x e to the power x. Okay. So we know that if there is any exponential function, we can write this exponential function here and you have to change this d by d plus 1. So d plus 1 whole square minus 2 into d plus 1 plus 1 into x. Okay. Now just simplify this d operator. So it will be d square plus 2d minus 2d. So that will be cancelled out. Plus 1. So I think it will be only d squared. So still let me write this plus 1 minus 2d minus 2 plus 1. So it will be cancelled out. And this 2d minus 2d will be cancelled out. So it will be only 1 by d square. Okay. So we already know that 1 by d is integration. So we can write this d operator in this form 1 by d x square. So if we integrate this x square, it will be x cube by 3. And if we integrate this function with respect to x once again, it will be x to the power 4 by 12. Okay, so this is our required YPI. So for this problem, the particular general solution. So for this problem, the general solution will be y equals to YCF plus YPI. So YCF is C1 plus C2 x e to the power x plus e to the power x x to the power 4 by 12. And you have to mention here that C1, C2 are arbitrary constant. Okay. Now, there is one thing that we discussed so many previous year question, but the thing is they may not repeat the same question. They can modify this question in this way. They can give you x cube e to the power 3x, or they can also give just e to the power x, e to the power 3x into x. They can modify this part, even they can modify this part also, this part also. But the method will be same. So try to understand the method so that if there is any type of question, you can easily solve those questions using this same method. Okay. So I hope this part is clear, how to solve particular integral if the x function is in the form of one exponential and another, it can be any other function of x.